A very good morning to all. Today we are going to discuss about the Paschen Bach effect. In the case of an atom containing one single valence electron and an external magnetic field, and it was also assumed that the field was very weak as compared with the internal fields due to the spin and orbital motion of the electron. When the external field becomes greater than these internal fields, the internal motion are greatly perturbed and the atom give rise to Paschen Bach effect. In a strong magnetic field, the coupling between L star, S star breaks down and J star loses its significance. In the case of sodium atom, the uncoupling of L star and S star does not occur for the values of B magnetic field up to about 0.1 Tesla. When this magnetic field in between 1 to 10 Tesla, the precession frequency of L star and S star around J star is of the same order as the precessions of J star around B, and the coupling of L star and S star begins to break down. If B is further increased, what happened? The coupling between L star and S star completely break down and L star and S star precess independently around B. That is the Paschen Bach effect. That is, the anomalous Zeeman effect is valid only if the magnetic field applied is not strong. When B is strong, what happens? The spin-orbit coupling would be small compared to the magnetic splitting of energy levels. In such cases, mu L and mu S, that is the magnetic moment due to orbital and spin motion, precess separately about the field direction. In the presence of a strong magnetic field, the anomalous Zeeman pattern changes over to the normal Zeeman pattern. This phenomenon is referred to as Paschen Bach effect. See this figure, that is, here L star and S star precess independently around B star. Now, the projection of L star around B is given by ML, and similarly the projection of S star along B is MS. ML can have the value L, L minus 1 up to minus L, that is L to minus L, that is 2L plus 1 values, and ML similarly MS S to minus S values. The total interaction energy with the magnetic field in the Paschen Bach effect involves three types of energy, three interaction energies. First is delta ES, that is the interaction energy of spin magnetic moment mu S. That is, delta ES is the mu S B cos of mu S B. That is due to the spin magnetic moment. And the next interaction energy is due to the orbital magnetic moment mu L. That is delta EL equal to mu L B cos mu L B. And the third one is energy due to a small amount of remaining interaction between mu S and mu L. And that is, if there is a nearest amount of the interaction energy between mu L and mu S, that is come under this category. That is delta ELS equal to HCA ML MS, where A is a coupling constant between orbit and electron spin momentum. Now, the total energy E becomes E equal to E0 delta EL plus delta ES plus delta ELS. Here, E0 plus delta ELS, that is E0 plus delta ELS, E0 plus delta ELS, that is the first term, and the last term is of the form of energy that atom has in the absence of field. and substituting these equations, that is substituting these three equations in this equation 4. So E equal to E0 plus mu B cos mu S B plus mu L B cos of mu L B plus HCA mu ML MS. And this is due to the, as I said, it is due to the small amount of the remaining interaction between mu L and mu S. And but we have mu L equal to E by 2m L star H cut, that is E by 2m L star H by 2 pi, and mu S is equal to 2 times E by 2m S star H cut. H cut means H by 2 pi, and cos mu S B equal to ms divided by S star, and cos mu L B equal to ml divided by L star. Combining these equations and also substitute the values for the magnetic moments, so therefore we will get E equal to E0 plus E2 into E by 2m H cut BMS plus E by 2m H cut BML plus HCA ML MS. That is E equal to E0 plus mu B ML plus 2MS plus HCA ML MS. The second term is very important, that shows the presence of the Paschen Bach effect. And what happens for ms equal to plus or minus half? This equation becomes E equal to E0 plus mu BB ML plus or minus mu BB. This expression for the energy is same as the one from the normal Zeeman effect, except the constant term mu B. The selection rule for this transition is delta ML equal to 0 plus or minus 1 and delta MS equal to 0. Next, we consider an example for the case of sodium D lines. Here, the sodium D lines, there are D1 and D2 lines, that is 2p 3 by 2 to 1 by 2 transition, that is 2p 3 by 2 to 2s 1 by 2 transition, that is D2 line, and 2p 1 by 2 to 2s 1 by 2 transition, that is D1 line. That we taught in the last class. And check the table, that is for the term 2p, there are two terms, 2p 3 by 2 or 2p 1 by 2. The L values are 1, S value 1 by 2, and ML values for L equal to 1, 1, 0, minus 1, and for the 2p half, another is 1, 0, minus 1, and MS have plus half, plus half, plus half, and minus half, minus half, minus half. And ML plus 2MS, that is the term that shows the effect of the Paschen Bach, that is ML plus 2 times MS. 2, 1, 0, 0, minus 1, minus 2. And ML MS 1 by 2, 0, minus 1 by 2, minus 1 by 2, 0, and 1 by 2. For 2s, for the term 2s, L can have 0, S can have 1 by 2, ML 0, 0, and MS plus half and minus half. ML plus 2MS 1 and minus 1. ML MS 0, 0. Since the levels with the same value of ML and 2MS for the same value of, that is 0, 0, for the same value of ML plus 2MS and ML MS, that is here 0, 0, the same value, and for the ML MS the same value, half, half, minus half, minus half, and 0, 0. That is the same value of ML plus 2MS and ML MS coincide. We have 5 sublevels of P and 2 sublevels of S level, that is as shown in figure. and for the same value of ml plus 2ms and mlms, they are coincide. So we will get only 5 sublevels. And check here for the anomalous Zeeman effect, 2p half split into 2 and 2p 3 by 2 split into 4. There are normally 6 lines, 1, 2, 3, 4, 5, 6 lines. But in the case of Paschen Bach effect, there are only 5 lines, on 1, 2, 3, 4, 5. The reason is that the same value for ml plus 2ms and the same value for ml/ms, they are coincide. So there are only 5 sublevels. And applying the selection rules, that is delta ml equal to 0 plus or minus 1 and delta ms equal to 0, applying the selection rule, we can see that 5 lines result from the sodium doublet, although there are 6 lines take place. This is because the spacing of the energy levels is such that 2 levels of the lines coincide. The splitting of 2s half, 2p half and 2p 3 by 2 levels and D1 and D2 lines of sodium atom in the presence of weak and strong magnetic field, that is shown in this figure, and the spacing of energy levels is such that ml/ms, that is 0 1 by 2, 0 1 by 2 to 0 1 by 2 and 0 minus 1 by 2, 0 minus 1 by 2 transitions results in a line of the same frequency, that we will get only single line, 0 1 by 2 to 0 1 by 2 and 0 minus 1 by 2 to 0 minus 1 by 2. We will get only the single line. And so closely watched this figure, this is no field, that is in the absence of the field we will get D1 and D2 lines, but we apply these lines is due to the internal field. If we apply any external, this internal field is due to the internal motion of the spin and orbital motion, that is interaction between spin and orbital motion. If we apply any external field, that weak field, we will get anomalous Zeeman effect, that is these lines again split into the up to 10 lines, that is 4 for the D1 lines and 6 for the D2 lines, therefore totally 10 lines. But if we apply strong magnetic field, what happens? L star and S star presses around B independently. And also note that the same value for the ml plus 2ms and ml/ms levels are coincide. So there is only 5 sublevels for the P term. So in this we will get the transitions like this. Okay, thank you for watching.